I had question 6 for worksheet 9, which said let G be a group and fix A an element of G, and we had to prove that phi A mapping from G to G is defined by phi A of x equals AX inverse of A, and we had to show that that's an isomorphism. So the first thing that I did for this proof, I said that let G be a group, and I said and A is an element of G. And then our first step whenever we want to prove something's an isomorphism is just defining what phi is. So I said let phi A from G to G be phi A of x is equal to AX A inverse for all of x and G. So the first thing that you have to do when you prove something's an isomorphism is that you have to prove that it's one-to-one. So first let's consider phi A of x is equal to phi A of y, knowing that y is also an element of G. So going back to the definition of the function, we know that phi A of x is equal to AX A inverse, which would be equal to now the same thing but now with a y. So now since we have the same things, we can cancel, so then we have x is equal to y, therefore phi is one-to-one. Next thing that we have to do is prove that it's onto. So let's next consider phi A of A inverse XA. So now we can apply the function to this element. So we get A inverse XA, A inverse. So now regrouping this, we can get A inverse X A inverse. The A inverse will go to the identity. Now we have just X. So this proves that it is onto. And then lastly, our last step in proving something's an isomorphism, we have to consider phi A, phi B is equal to phi AB. So for this one, lastly, let's consider phi A of x, phi A of y. So now applying both of the functions twice, we have AX A inverse times AY A inverse. So now regrouping this, we have AX group A inverse A, Y inverse A. The middle becomes just the identity, so now we have X, E, Y, and then we'll have the A inverse. The identity just goes away, so then we're left with A, X, Y, A inverse, which would equal phi of A of X, Y. So now that we've had all 4 steps proven, we can say phi A from G onto itself G so that phi A of x is equal to A x A inverse is an isomorphism. And since it's mapping from itself to itself, we know that it's a automorphism.